Hey guys, welcome to Skill Link. In our daily life, we come across several processes in which a newly created object can be reverted back to its original state. For example, when we put ice at room temperature, it melts and turns to water. However, when we put the same water into a freezer, it turns into ice again. Such a process which can revert to its initial state or a previous state is called a reversible process. We also come across some processes where the newly created object cannot be reverted back to its original state. Say, for example, producing mango juice from mangoes. You cannot reverse it back, so it's an irreversible process. In today's video, we'll talk about reversible and irreversible processes and an additional topic called quasi-static processes in thermodynamics. Let's start with quasi-static process first. For us to understand the quasi-static process, we must have a clear understanding of thermodynamic equilibriums. In our previous video, we talked about thermodynamic equilibriums. If you haven't checked it out, the link is in the description below. Now, what is a quasi-static process? Let's take a small example. Let's consider a cylinder filled with gas. This gas is being compressed using a piston. 3 weights are placed on the piston which regulates how much pressure is applied by the piston. Let's call the initial state with 3 weights on the piston as state 1. Now, one of the weights is removed. Because of this, the pressure and volume in the system changes. Let's call this new state as state 2. Similarly, another weight is removed and the new state, let's say state 3, is obtained. Finally, the last weight is removed and the final state is obtained. We'll plot this on a PV diagram. As you can see, there are 2 intermediate states between state 1 and state 4. Namely, state 2 and state 3. This means that the gas under compression has to pass through states 2 and 3 to reach state 4. According to the theory of quasi-static process, this change in state is infinitesimally slow, and it can be assumed that a thermodynamic equilibrium is established in each of the intermediate states. In simpler terms, a quasi-static process is an ideal process in which a change of state occurs at an infinitesimally slow speed, such that a thermodynamic equilibrium is established in the system at each instant. Such a process cannot be completely realized, and hence, all processes going on in nature are non-quasi-static. Now let's move on to discuss what is reversible and irreversible process. In thermodynamics, a process is said to be reversible if it can be reverted such that the system and surroundings get back to their initial states. There should be no other change anywhere else in the universe. In reality, completely reversible processes do not exist. Even in the example of melting ice that we talked about earlier, there is always a small part which cannot be completely turned back. The reversible processes are idealized cases of real processes. The purpose of creating these idealized cases is to determine the maximum efficiency a system can provide. A few examples of such reversible processes are extension of springs, slow adiabatic compression or expansion of gases, and frictionless motion of solids. On the other hand, there are thermodynamic processes in which the system and surroundings do not revert back to their initial states. Such processes are called irreversible processes. You can consider the burning of fuels as an example for this. When we operate a vehicle using fuel, the combustion process takes place which consumes the fuel and helps in operating the vehicle. This combusted fuel cannot be retrieved and brought back to its original state, and hence it can be considered as an irreversible process. They are called irreversible processes because energy is lost in some way or the other that makes the process not completely reversible. Most of the forces taking place in nature are irreversible. Contrary to this, the reversible processes do not truly occur in nature, and just as we mentioned earlier, the reversible processes that we study are the idealized cases of real processes. There are always some losses taking place during any process, as a result of which no process can be truly reversible. In this session, we talked about quasi-static, reversible and irreversible processes. This is Skill Link, and we'll see you on the next one. Bye.